Hi, welcome to my project bazaar.com. Now I'm going to minimizing file download in peer-to-peer networks. Here is the abstract peer file sharing applications are becoming increasingly popular and account for more than 70% of the internet bandwidth usage. It shows that a typical download of a file can take from minutes to up to several hours depending on the level of the network congestion or the service capacity fluctuation. In this project, to consider two major factors that have significant impact on average download time, namely the spatial heterogeneity of service capacities in different source pairs and the temporal fluctuation in service capacity of a single source pair, and also point out the common approach of analyzing the average download time based on average service capacity is fundamentally flawed, and also prove that the spatial heterogeneity and temporal correlation in service capacity increase the average download time in peer-to-peer networks, and then analyze a simple distribute algorithm to effectively remove these negative factors, thus minimizing the average download time, and also show that our performance evaluation outperforms most of other algorithms used in practice under various network configurations. Here is the DFT of our process. First, formulate the network formation. The network formation shows what are the pairs connected into the networks. Then moves to the connected pairs. The pairs are connected successfully. Then moves to the packet transformation process. In packet transformation process, move to file sharing process. In file sharing, we have to consider two methods: upload and download times. Upload and download process. Here the upload process, the peer can share the file to the next peer. In the download process, a peer can download the file from the requested peer, and also the transaction time and bandwidth and efficiency is also evaluated from the file sharing process. And also the efficiency evaluation is moved to efficiency evaluation. We have to calculate bandwidth and execution time for the file sharing process. So the bandwidth is taken at the what all the time sharing between the transaction between each and every peer, and also the time is a system level time calculation based on calculating the execution time evaluation. Finally, we will evaluate the best peer for selecting the packet transformation process. Let's move to one demo of our process. Minimizing file download in internet. Then moves to server configuration process. Here by clicking server means here the server configured successfully. Then moves to next process. Here the peer list shown here. Peers are connected. Select any one peer and select database connector. Then moves to interaction. Here give peer name as source. Here give destination peer name. Then choose input file. Here the input file is selected. Then by clicking allocate means the handover session start from peer 1 to peer 3. Then run peer3.java. Then click file resume. The file is received. And also give peer name for source peer name, and also destination peer name, and also choose the input file. Then allocate means peer 3 to peer 2, successfully direct to peer 2. Then run peer2.java by clicking receiving file, and also the source is act as peer 2 and the destination is peer 1. Then choose input file. Then by clicking allocate means peer 2 to peer 1. Peer 1 is already opened in the process. Then clicking receive file means file received. Then moves to download process. Run download.java. Here by clicking peer list means peer list or connector. Select any one peer and click database or connector. Then moves to interaction process. Here the source file name peer 1. Then click choose file, input that text. By clicking send request means the download request sent to peer 1. Here the same peer we have to queue. Then moves to here give service provider name. Service provider name is peer 3 means choose file and give send request and p3.java. Here the process is transferred to p3.java. Here by clicking receive records means the data will be received. Then clicking send file. So here the data will be sent. So the accept data is here accepted. Then moves to bandwidth process. Here the bandwidth process, the overall process is also evaluated. Here the service provider name is peer 1 means here also choose file, input file, send request, send to peer 1. Here we already run peer 1. Here receive request, then sending data, and also click then peer 3 accept data. Here the file is received. Then moves to bandwidth process. In bandwidth process, by clicking bandwidth, overall bandwidth of the all peers are displayed. Here the peer 1 take interaction, that means bandwidth value, and peer 3 take interaction, but peer 2 does not make interaction, that's the bandwidth value is 0. Then moves to speed process. Here the speed also evaluated for 3 peers. Then moves to process. Here the overall peer speeds, the which peer has the highest value is. These are the final graph of our process.